Hi, my name is Manognamalya Ramreddy, and this video presentation is about sarcasm detection using BioLSTM and transform-based models. Um, and the sarcasm detection in text data is a complex problem in natural language processing, particularly in online reviews, comments, and tweets. So, accurate decision is critical for improving sentiment analysis systems, which often misinterpret sarcastic statements. In this project, we developed a sarcastic detection system using BioLSTM and transformed-based models. So, the BioLSTM is bidirectional long short-term memory. It's a recurrent neural network capable of understanding sequential data, focusing on word order and context. While the transform-based models, which are Distilbert and Roberta, the Distilbert is lightweight transformer model with the fast training and inference, whereas the Roberta is a pre-trained language model, which is an advanced transform-based model, robustly optimized for state-of-art performance on NLP tasks. So the data sets we used here is mentioned here, and the data processing, the below are the steps that applied for this model. So for the tokenization, we use Glow for Bilustium and tokenizer for Distilbert and Roberta, whereas the padding for uniform sequence lengths and train validation data test splits. So for the specific differences, Bilustium used Globe embedding for vector initialization, whereas pre-trained tokenizers from Transformer library are used for Distilbert and Roberta. So this is the code we've developed, and first we imported all the libraries, and then we loaded the required data. And for the pre-processing, we did the tokenization, stop word detection, padded sequences, and all such to clean the text data. And then we loaded the pre-trained globe embeddings. So and then we built BioLSTM model. So the BioLSTM approach here is a design of a custom model with two stacked BioLSTM layers to extract sequential patterns, added dropout layers to prevent overfitting, and a dense layer for classification, and also optimized the hyperparameters using Keras tuner, achieved the best LSTM units, dense layer size, dropout rate, and learning rate. So here, after training the model here, we plotted the graph or loss over epochs and accuracy over epochs, whereas the accuracy is increasing. And then the after testing the model, we got the results like validation accuracy is 0.8, which is almost like 85%, whereas the time elapsed is 27 minutes. And similarly, we've done for we trained Distilbert also. So Distilbert is a lightweight transformer-based model for sequence classification, and the tokenized input text using the Distilbert tokenizer. Fine-tuned here, the fine-tuned the model using Hugging Face is a TF Distilbert for sequence classification. After this, we've obtained results. So yeah, after the finishing of training, we've got this accuracy of 0.71%. It's detecting sarcastic and non-sarcastic, but the accuracy is very low. And then we trained for model Roberta. A Roberta is a transform model fine-tuned on sarcasm detection, and it's tokenized text used using the Roberta tokenizer and trained using Hugging Face trainer API. So used classification labels to identify sarcastic and non-sarcastic comments. And after um, training this Roberta, we've got the results like this, and the accuracy is 1, which is really 100%. And then the validation loss and training loss are really very low. And then I have printed the BioLSTM accuracy, Distilbert accuracy, and Roberta accuracy. Whereas the result impact is the performance of models was evaluated as using the accuracy. So BioLSTM is 84.24%, while the Distilbert is 62.95% only. As Roberta got 100% superior performance accuracy at understanding the complex language. So Roberta emerged as the best model, showing its ability to capture context and linguistic subtleties effectively. So and also for the model architecture, if the A bi-LSTM is embedding layer initialized with globe. Bidirectional LSTM layers has 64 and 32 units, and it has dense layers for binary classification, whereas Distilbert is a pre-trained transformer model with the fewer parameters, fine-tuned with Adam optimizer, and learning rate is 5E5. And also for Roberta, it's a pre-trained transformation model with the robust optimization and fine-tuned using Hugging Face training API. The key parameters is learning rate is 2E5, whereas the batch is 8 and epochs is 10. As the evaluation metrics I've already discussed before, the accuracy of BioSteam is 84%. For distilled is just 62%, while the robot is 100%. And the recall F1 scores, a micro average, weighted average is also mentioned over here. Whereas the recall for every metric, the robota is having the 100% accuracy. And After evaluation, this is a plotted graph. The BioSteam is suited for smaller data sets, slower but interpretable, whereas the Distilbert is lightweight, fast, and efficient for low resource environments. Roberta is the best performance overall, requires more computational resources, but as it requires more computational resources, but still its performance is really good overall. And the summary of my findings is that Roberta is outperformed other in all metrics, but it's computationally very expensive. Whereas Distilbert is a balance between speed and accuracy. BioLSTM is a good baseline for smaller data sets or interpretable focused tasks. So I recommend Distilbert for real-time applications, whereas Roberta for high stakes tasks requires maximum accuracy. So the contextual understanding of transformers outperforms sequential models like BioSteam, whereas the hyperparameter optimization is crucial for enhancing BioSteam performance. So sarcasm detection can be benefit from more sophisticated training data in that cases. And the here the pre-trained on expensive data capable of detecting subtle sarcasm patterns. So uh, Roberta is the excellence for the in all the models. Thank you.